Hey everyone, and welcome. Today, we are diving into something really cool. How do we get AI to read huge documents, not just word by word, but more like we do, taking in a whole page at once? It turns out, researchers have found a brilliant new way to make AI a much smarter reader.
So let's just start with the big question, the one that kicks this whole thing off. Can an AI look at an image of a page, or even an entire book, and just get it? Instantly understand all the text without grinding through thousands of individual words? It sounds simple, but it's actually one of the biggest challenges in AI today.
So here's our game plan. First, we're going to look at the core problem, why reading is so hard for AI. Then we'll get into the clever solution, using images to compress text. After that, I'll introduce you to the system that actually does this, DeepSeek OCR. We'll peek under the hood at its design, and finally, we'll see if it actually works.
All right, let's jump right in. Section 1, AI's big memory problem. Now, you might be surprised that an AI can get overwhelmed by reading too much, kind of like we do, but the reason it gets overwhelmed is totally different, and it's pretty fascinating.
Okay, so here's the main issue. For a lot of AI models, the more text you give them, the exponentially harder they have to work. The technical term is quadratic scaling. But here's an easier way to think about it. Imagine you're reading a book, but for every new page you read, it gets twice as hard to remember all the pages that came before it. That's the kind of massive inefficiency we're talking about, and it makes reading long documents super slow and really expensive.
Now, what's really interesting is that researchers already tried using AI's vision to fix this, but the first few attempts just hit a wall. Some of the models were way too complicated to train. Others would chop the page into so many tiny little pieces that it completely defeated the purpose. And a third type was just a total power hog, using up way too much GPU memory. It became pretty clear they needed a totally fresh approach.
And that fresh approach? Well, it's both really simple and incredibly elegant. The thought was, what if instead of fighting with the text itself, we could just change how the AI sees the text? And that brings us to this idea of compressing text using images.
This big idea is called optical compression, and it's pretty straightforward. Instead of feeding an AI a long string of words, you just give it one single image of the document. That one image holds all the same information, but it's packaged in a way that a vision language model can process way more efficiently.
And this right here, this just perfectly illustrates the power of that idea. So a document with 1,000 words needs about 1,000 text tokens, or little pieces of information, for a language model. But if you turn it into an image, a vision model could potentially represent that same info using just 100 vision tokens. That's a 10x reduction in the amount of work the AI has to do. That's huge.
Okay, so theory is great, but how do you actually make this optical compression thing happen in the real world? Well, researchers at DeepSeek AI went ahead and built a system designed to do exactly that. So let's meet DeepSeek OCR.
DeepSeek OCR, and that OCR stands for Optical Character Recognition, is a brand new vision language model. Its whole purpose was to prove that this optical compression idea isn't just a theory, but that it can actually work. It's a system built from the ground up to be insanely efficient at reading text right from an image.
And the system basically has two parts that are a real dream team. First, you've got the DeepEncoder. Its job is to look at a high-res image and intelligently squish it down. Then you have the DeepSeek 3B mode decoder. That's a mixture of experts model, which is perfect for specialized tasks like this. It takes that compressed info and perfectly reconstructs the original text. It's a compression and decompression powerhouse.
So let's pop the hood and see how the magic actually happens, because their real secret sauce is inside that first component, the DeepEncoder. Its entire reason for existing is to take a giant high-resolution image and, without even breaking a sweat, spit out a tiny, super compressed version.
The design is this really clever three-stage funnel. So first, a part of the AI called SAM scans little windows of the image, picking up all the tiny local details. Then, all that rich information gets squeezed by a compressor, which shrinks the data by 16 times. And finally, another part of the AI called CLIP looks at this compressed data and figures out the big picture context. It's this awesome process that goes from super fine detail to a small, meaningful summary.
And here's the bottom line. For a pretty standard high-res image, the process starts with over 4,000 vision tokens. But after it goes through that clever funnel we just talked about, it comes out with just 256. That's how it completely sidesteps those memory problems we mentioned at the beginning.
All right, so the idea is smart, the engineering is clever, but you know the big question that's always left? Does it actually work?
Well, this is where we look at the results. The proof, as they say, is in the numbers.
Check out this table. This is really telling. It shows that when the compression is less than 10x, so 10 times more words in the text than there are vision tokens, the model is an incredible 97% accurate. Even when you really push it, compressing it almost 20 times, it's still holding on at about 60% accuracy. That is a seriously good trade-off.
And this chart just brilliantly shows off its real-world efficiency. So on this test, DeepSeek OCR beats a leading model called Miner U 2.0 while using less than 800 tokens. Look at Miner, it needs over 6,000. And it beats another model, GOT OCR 2.0, using just 100 vision tokens compared to its 256. I mean, it is doing way more with much, much less.
And hey, don't just take my word for it. The researchers themselves said it best. They concluded that this is a huge step forward. This isn't just a tiny improvement. They see optical compression as a really promising path for the whole future of how AI deals with information.
So why does all this matter? Well, beyond just reading PDFs faster, this opens the door to some seriously mind-bending ideas. Think about how our own memory works, right? Recent stuff is crystal clear, but things from years ago get kind of compressed into a blurry summary. This technology could let an AI do the same thing. You could store recent important info as high-res images and then older, less critical data as smaller, blurrier images. This would save a ton of resources, and it might just be a step towards a more natural, human-like AI memory.
And that leaves us with one last thought to chew on. We started with a pretty technical problem about reading documents, and we've ended up on the edge of creating an AI with something that looks a lot like human memory. It just goes to show you, solving one problem can open up a whole new universe of possibilities. The question isn't just if an AI can read a book in a single glance anymore, it's what on earth it's going to remember.